Hello, hello. Yeah, seems like we are live. Hello, welcome everyone again to the Code with Buda. I'm back after a while. Hopefully today we'll try to do a bunch of fine-tuning with Cypher queries and generate some easy to use LLM, SLM that is accurate on the Cypher data. I already did a bunch of stuff in preparing this, but still results are not great, even though we are moving in the right direction. I'll try to probably share the screen and then see how well we can get. Basically, I'll explain a bunch of the to kick off. Basically, there is a bunch of taking the LLM and then just adding a bunch of training data. Basically, one of the main issues with training is the amount of data is there. It has to be somehow provided, and yeah, it has to be accurate. It has to be diverse. It has to be a lot of different things. So this is going to be probably the focus of the today video. Actually, trying to get a bunch of data in, and then the second big thing is the validation of the data model, and how to actually get what you want, and how to validate it, how to compare models across different training processes and different training outcomes. Yeah, seems like hopefully my stream is gonna work. Now everything is okay. If something drops, I'm also recording, so I'll upload that later on to YouTube. Hopefully that will be all right. But yeah, let's get started. So I'm sharing just let's say a state of my experiment so far. There is already zoom in a bit too so that it's visible. Hopefully that's okay. Yeah, that's all. Yeah. Okay. Here I have a bunch of Python files and different queries where I actually train the model. So I already have some working example which goes into the right direction, but still there is a lot of work. So let's get. I totally removed all the repo before, so let's get started here. Let's initialize these things. Yeah, to point out, I'm actually using. So I won't go into probably too many details of LLMs, SLMs, and how they actually work. But yeah, maybe on some other video, I'll just try to focus on getting some training results on default settings. Let's call it like that. But for the training, I'm actually using this amazing repo, unsloth. It has a bunch of ready-to-use models, and it's actually a bigger project where the goal is to, I guess, make the process of training LLM model super easy. They have a bunch of stuff here, so thanks for the amazing work. And yeah, I'll try to basically use that as a as a framework to train models. That's on one side. On the other side, there is also, so on this machine I'm connected to, I have two GPUs, two NVIDIA GPUs. That's also required to actually train something in a reasonable way. These are not super huge GPUs. These are like small size, small memory GPUs. They have like 12 gigs of RAM. That's, I guess, enough to train these small language models to a reasonable degree. So that's what I'm trying to figure out, how to actually get the most out of these small GPUs, and then have a small model which also has many advantages to actually generate Cypher queries. Yeah, that's basically it. Let's get started with the. I hope this is okay. I'll maybe make it a bit smaller. Yeah, this should be fine on the. Let me know on the phone, in the comment how does that look like. Can you see on the phone if you're watching on a smartphone? All right, so here is the unsloth repo, which is going to be installed, but then there is also a few of these extra dependencies that have to be installed as well. I'll just run this as quickly as possible, and then we'll move on. SV3, this is just the start virtual environment. I think SV3, I had this on some of my previous examples, so yeah, previous live streams. So this will start the virtual environment, Python virtual environment. Yeah, now we have virtual environment, and let's activate it and then run init. So the init will install some of these things, some of these libraries. It usually take this will actually download. Yeah, I had them in cache, but yeah, using cached. Yeah, great. This will take some time, so let me just explain. So under this repo, there are a bunch of dependencies which are required. So pip install these NumPy PyTorch PSUtl transformers. This is all required for the unsloth to work, to actually fine tune and run LLMs. But in addition to that, I also have a few of these other dependencies, because so I will take a bunch of Cypher queries from Memgraph repo to actually train on them. That's why I need Gecrin to actually parse the BDD style tests, the Cucumber encoded tests. From there, I'll take the Memgraph Cypher queries, and also, yeah, OpenAI will use OpenAI to actually. So the problem is that based on these queries, I need to actually generate a lot of training examples, and ideally humans would write them one by one, but since there is not a lot of humans to do that task, I'll just use ChatGPT to actually generate the training samples. Hopefully that will yield good results, but we'll see. Anyway, to do that in automatic way, there is also dependency. And then this weird thing here, yeah, this is still installing. This weird thing here is just like dependency management thing. I guess some of these libraries are conflicting, and yeah, maybe that's because I have some of these libraries here, and that's maybe conflicting with this. And the fact that I'm using directly pip, so not something like Poetry or some other dependency manager. I had to install specific version of protobuf library. Okay, great. I think this is This is successfully finished. Yeah. One of the things is also I have here the small Python script to actually check the GPUs. So let's run that. H3 W inspect. Yeah, so we can see from Python that we have here 2 GPUs. I forgot to mention that, but you actually need to install the NVIDIA driver and all that under the system. That's probably a bit of a challenge, but shouldn't be too hard to actually get NVIDIA driver up and running. And once you do that, then it's relatively easy to just install these Python dependencies and get started. They also libraries like Torch and others are automatically detecting if there is a GPU, and they install appropriate seems like something dropped for a second. Okay, let's get back to the plan. So I'll explain as I go through all of this. I'll explain the stage and what everything does. But what I already did, that looks like. Let me just find the right file. No. So this is the that's for the where is that? Yeah, so this is the template actually. So like this is the prompt to actually get the right human question, because what we want to train the model on for a given human prompt to generate the right Cypher queries to actually extract data from the database. And in order to do that, I just prompt an LLM to, in particular ChatGPT, to give me that query. So sorry, the prompt, and then in the first person, in between 50 to 100 words, ask a question that would a user in domain ask Memgraph to get the following Cypher query, and this query is injected. So based on the testing query we have, this query will be injected here, and then this prompt will be sent to ChatGPT to get actually a human prompt. That is expected for a user to be written in the beginning when interacting with the end system. That's one example. And second, so we have, it's not just one template. The whole point is to also play with the different templates. And for example, here, the second template is imagine a user in any business domain. Ask a question that would a user ask Memgraph to get the following query, and then again query. Sometimes, yeah, LLMs try to explain what is happening under the query or some additional non-useful stuff, because yeah, when a user prompts an LLM, user doesn't expect for a query to be, he doesn't know about the query at all, so it's totally useless to explain that query in human words. Maybe it is some certain cases, because if the query is totally one-to-one mapped to the reality, but that's, I think, rarely the case. But anyway, this is also something to experiment with. Yeah, so these are the prompt templates we're going to use to generate training examples. And then we have these examples prepared. So this is actually under I'm trying to store all these steps and intermediary data points. So let's say here it's a bit messy. I'll also move myself here. This is a bit redundant, but query is actually, so one of the testing queries is this here, unwind 13 as x return case. This is a very specific testing query. So obviously we don't have like crazy good queries to start with. We have a bunch of testing examples, but let's say for this query, what's gonna be generated in the first iteration, in the first step, in the first person Lala for a query unwind, and I also added, let's say in cybersecurity domain. That's an interesting domain to train for graphs in general to be used in. So for that particular domain, what would be the query? And that was the prompt sent to ChatGPT, and the answer was, so I have here do I have them in order? I should. Where is that? Just a moment. Let's find that query. Find range. Let's find for unwind range. So this is the unwind range, and then prompt question. So so this was actually generated by ChatGPT. I'm analyzing potential threats within our network. How can I craft a query in Memgraph to sequentially evaluate a list of security events, event codes, and return specific levels for certain codes, enhancing our data categorization? This is actually very like creative prompt in the end for this type of query. It's not super accurate, I guess, because it has a bunch of additional details, and the initial query is very bad for to conclude something. But I guess it's right in a sense that there is certain list, and then sequential access. You're actually doing the sequential access through the list, and then you're doing some like imperative logic case then and stuff like that. So it's not totally off, but it could be much better probably. Anyway, but this is just one example. There is a bunch of, so here I have like 28. I just took a few of them, a few of these testing queries, and then generate these things. So that's so these queries are actually coming from Memgraph Cypher test framework. It's called TCK, Technology Compliance Kit, for the Open Cypher project. So I just took that's from the actually I can actually now I have visual features. This is the repo. It's actually written here. So So these are the so Memgraph test, GQL behave tests, Memgraph tests, Memgraph v1 features. So these test cases in the first example, in the first file, are coming from here. So we just took, I think I did one of each feature. Let's say this query here is taken, and then the final prompt is generated. So these are the TCK examples, and there is many of them. So there are hundreds, like thousands of these queries there. We will probably play a bit more with that and load more of them as we train. So we'll see about how to get accurate responses. But again, that's one of the main challenges. So how to actually evaluate responses, I think that's going to be the focus of this whole stream. Yeah, that's one example, and the second example is very similar. Parse MAGE. So under Memgraph MAGE, there is also a bunch of these queries in a form of these end-to-end tests, and from here it's also so parse MAGE. This is not in the Cucumber format. This is just our own format. For example, yeah, input Cypher is a graph against something is tested, and test is actually here. So for a given query, in this case bipartite matching, this is the result. Yeah, one also important thing here is that Memgraph does a lot of these graph algorithms. For example, bipartite matching, or maybe better example is the PageRank, or other or community detection algorithms are a big deal these days. And for them, it's very hard for an LLM to actually figure out, oh, for this type of question, I have to generate, I don't know, PageRank call. That's a special set of queries against which LLM has to be trained. And these examples are good because there is a lot of these mentions what has to be done in the training process. Additional context has to be added. For example, how I can use bipartite matching in a given domain, or PageRank, or community detection, so that actually I know. For example, one obvious example is when you want to ask, give me the most important, I don't know, doctor in the graph. LLM has to generate PageRank as a call, as a procedure call, and that's super hard without seeing the training examples. Okay, a few concurrent viewers, that's great. Let me know about any specific thing to cover. I'm glad to move out of the plan. All right, that's about it. So that's where these training examples are coming from, and stuff like that. So these are the parsers, MAGE stuff, yeah. And yeah, train the first set of TCK. So I will try to train some simple model, and I think there is some really good result with more queries, and especially more diverse queries. But let's get actually to a serious thing. So one thing I would like to cover before moving on is how does actually model work without training. So this thing here. So run tests against the base model. Some basic two prompts. This is just initial test. I've actually experimented with just adding a few simple prompts, and then these additional bigger models. Yeah, I'll try to get. I actually didn't do that in the first place. I'll just try to load a model and then run some initial test on it. So here I have additional thing is which model am I using. So there is a bunch of these models here, different ones, and yeah, here I'm not sure if this actually worked. I have the Phi 3.5 model. I think that's Microsoft model. This is like a small language model with, I think, a few, like 1 billion parameters or like 2 billion parameters. And this is working relatively smoothly on the GPU. 3 billion. Let's try to run this. So what is happening here? Generate model. I just have something. Will this work? Generate prompt, print response. Chat SLM Python. Chat SLM. What's gonna happen here? Now it's gonna load the unsloth. This is because the unsloth has been imported in the beginning of the script. The question would be, what did I run? Yeah. Just push some input, not create, Why is that not running? Wait. I'm not sure why test, and why is that? Because we are actually running so we actually got here sorry, just to initialize a bit more. to see what is happening. So we're gonna print this prompt, and then this input is sent directly to the model for inference, and then that will be used. Yeah. And again, so get back to the model. Model is actually unsloth llama 3.2 3 billions. And maybe just to see, since that's a 3 billion model, yeah, it's not how to get. Yeah, I'm using a funny thing here is that I'm using the Google. I'll switch to ChatGPT or something else soon. I can also make a small prompt to actually give me answer to these queries. But okay, let's how to get memory usage. Yeah. Useful SMI queries, yeah. GPU name. Query, yeah, we need this. Memory usage. Where is the query? Memory. So NVIDIA semi query GPU format CSV query GPU. Yeah, and what's the valid what's the valid name? I guess GPU memory. Nope. Is query GPU. Help query GPU for more info. Query GPU. Yes. So what I'm trying to do, I'm trying to get like a small number because of the screen, because the screen. I zoomed in to have a big letters, but that breaks the NVIDIA SMI output. So I'll just use something small here to memory used. Memory dot used. Great. So I need here memory dot used. Yeah, that's what we need. Let's get back here and then watch NVIDIA SMI query GPU equals memory dot used format CSV. Okay, that will write every 2 seconds the memory, but no. Watch. Help. Where is the time interval? And watch and 0.2. Yep. And now we run that and let's see what's gonna happen, because at some point the GPU memory should be loaded with the model. Yeah, as you can see here, so 2.8 gigabytes was the most used memory. Yeah, that's interesting. That's also, I mean, the phi. Yeah, this is the just coffee. Don't worry. Yeah, okay. What next? Okay, let's just, okay, this is it. And how to make sure that, yeah, I don't have stored model currently here, so this is for sure the llama 3. And then I'll just, so generate prompt. Yeah, here is it's a bit challenge to, okay, let's get back to the goal. So the goal is to run the base model with the given prompt and get how well the base model will generate a Cypher query. For that, we do have these templates, but these are templates for training. We need templates for inference, and this is here. So this is the actual inference thing. Yeah, here I was training a model, so I'll actually change this script. User question. Yeah, but yeah, this was an old script. Let me just use it here because I have everything prepared here. So play model. Let's go here. Model name is this one. And then why is my order late? So for a given model, which is llama 3.2, and let's actually try. So let's actually try llama and phi 3.5. Where is that? I delayed somewhere with that. Yeah, this one here. So let's do first model name equals this. We don't need that. Okay, if I run play model, So play model, Python play model. This should run. So I probably didn't explain very well because I have some prepared work. So here I'm running 3.5 model on this prompt. So below is an instruction that describes the task, write a response that appropriately completes the request. And then instruction in response. So user question is this. Why is my order late? That will be injected here, and then response will be generated. These like LLM models have a certain like template for the prompt, and on that they will be generated. So essentially the context window. So this is all the context window there, and that will be used here. So the problem here is that I'm actually expecting a Cypher query here, not this response, because we are training the model to generate the Cypher query, but it's reasonable because the model doesn't know anything about Cypher and I didn't instruct him. It's not trained on Cypher and it didn't have any instruction for the Cypher, but I'll just, so because we need these templates, I'll actually refactor this a bit. ChatGPT, so I'll centralize that in a way that prompt templates prompt template.py, yeah, and then I'll move this under prompt template, and these are ChatGPT prompt template. I don't need anything here from the dependencies. And then, so this is ChatGPT, and let's say Cypher prompt template equals something. So yeah, at the moment I'm just trying to centralize the code so that we can use it from multiple places. So this is let's call it template. When obviously I don't have a good names for this yet, but we're gonna come up with that later on. So Cypher prompt template, user question, lambda. So we need lambda here, user. So I'm not explaining some basic stuff probably, but if you have any additional question, just ask in the chat or wherever you want. Now I played my stream on another. Yeah, okay. Just ask. So I'll just move on with these basics. I can explain them as we move on, but yeah, here basically we have to inject the user question, and for that we're gonna use Python lambda expression. So user query. Why is that was not closed? Expected expression. Yeah, user question, sorry. Okay, great. That's actually template 1. And let's just get back to fix. So Cypher prompt template 1. play model. So from play prompt template import Cypher prompt template. Cypher prompt templates. Sorry. Cypher prompt templates, and we need template 1 here. So Cypher prompt templates, template 1, and we need to pass user question. Okay, so we just reused that one, but we also have to fix, because I made a mess by moving this here. We also have to wow, we have a few, we actually have a few of these templates that should be centralized. So I took it from here, AG, wherever I'll search for, wherever that template has been imported, and that's import ChatGPT, but AI LLM AG import ChatGPT. No, I'm sure this should be used somewhere. Yeah, from, sorry, from. So train dataset here. This is a little bit of refactoring, I guess. That's always healthy. So we still have this, but we don't have this. So prompt template ChatGPT prompt templates, yes, but we don't need this here, and we don't need this here. Why not? Prompt template. Who knows? Yeah, we can run this. This will actually. So here I have a bunch of these files from before. Here I can run them just to verify. Why is that not working? ChatGPT prompt templates, yes. Prompt template. So train dataset, okay. We don't have OpenAI key. We're gonna fix that later on. For now, let's ignore that. And here as well, from we need it also below. Yeah, that's working. I'm not sure why my IDE is complaining. That's okay, I guess. Where else is that used? GPT prompt. So this usage is okay. That's okay. It's imported from the right one. And this one is also right one. Okay. Perfect. So let's get this back. All right. Generate prompt in close to 50 words. Sorry, I got lost a bit. How did we ended up here? Play model. So here, user question. I wanted to add a Cypher into the template, so I'll actually change this or expand that a bit. So template 2. So below is an instruction that describes the task. Write a response that appropriately completes the request by generating a Cypher query. Okay, so this now should give the LLM enough context to actually try and generate Cypher query. And now, play model, we're gonna try with template 2. What's gonna happen now? And we run Python play model. So let's make this a bit bigger. Yeah, memory usage on the GPU is still the same. So as you can see now, below is an instruction to generate Cypher. Why is my order late? So my instruction is the query, the user question is actually why is my order late? And the response to answer this question, you would like to need a query, a database that tracks orders, their status and expectations. I guess also the issue is that somehow the response is cut. Boxing. Let's try to just I'll just try to cut write the response in no, maybe I probably just took the first one here. No, wait, I think that's actually the problem. So what if we write all the responses here for output in tokenizer, print output. But this will take some time. I guess it's output is chunked, and then I don't see everything. Yeah, no, this is just characters. Oh, sorry, wrong. Page decode, outputs, boom, output, boom. I just iterated on the whole sentence instead of the chunk. But it's also one. Max tokens 64. Max new tokens. I guess this might be an issue as well. So what if we say here 1,000? Boom. All right. So now we have the full response. I actually end of text. Wow. I just realized I did the whole thing wrong. Yeah, okay. Now we have the full response. So for this, to answer this question, we would need to query a database that tracks orders, their statuses, and expected times, blah, blah, blah. Cypher, in this query, you would replace order ID with the actual ID of the order you're running. Yeah. Yeah, this is actually not bad. Let's now go and train something finally. Let's put this back because we actually have here 0. That was before we only got one of these responses. That's sure to get the same type of thing, type of response. I didn't see the comment. On air. I have some issues with the internet connection, but yeah. All right. Yeah, I got the same response. That's great. Okay. Okay, what if we switch to Llama 3.2? Is this running slower? Okay, this is completely different. Response. So in this particular case, the prior text cipher query that is used to retrieve information about. Here is the correct response. How is that different? These are the different. Is late for a late reason. If a late reason is a property on a node, or versus if that's encoded somehow as another node in a node with label late reason. And then there is the whole explanation for this. Yeah. I guess this is a bit better response overall. Okay. I also no idea why the stream was recommended. Yeah, this is quite technical. I'm not sure if what are you Vasco? Yeah, what are you looking for? PhD AI. Yeah, well, I mean, this is relevant completely. So I'm trying here to actually fine tune an LLM model to generate Cypher queries. So yeah, this is fairly practical. So I'm not super deep into the theory yet, how the LLM models work and stuff like that. But it's more about how to practically get LLM fine tuned on a given. What's your dataset? So my dataset is here. The queries from testing cases of Memgraph and MAGE. So this is a bit pre-processed already, but datasets are, so if you can see the screen now, these queries are, I'm trying to extract them and make training examples. Basically here we have under this Memgraph v1 folder, there is a bunch of different queries, and yeah, I'll try to extract all of them and make the training examples. That's one like training source, and the second one are all these tests. For example, let's say cuts. I think that's a centrality algorithm. So for example, here we have a query that runs the cut centrality on a dataset. So yeah, basically that's the idea, how to get the data, but the training samples have to be generated because this is not this is completely different format, and we have to somehow extract them and pass them into the training process. Yeah, so is it domain specific? Yeah, so it's in the database domain, generating the right database queries so that you actually can generate the right data. It's the end goal is to do RAG, retrieval augmented generation, but based on these generated queries, data is extracted from a database and then passed forward into an LLM to generate the right responses. So it's domain specific to a database, and then to a database domain to these queries. But yeah, then what I'm trying to do here also, so with these templates, for example, user prompts will be specific to a given domain. For example, cybersecurity or fraud detection or I don't know, logistics. And then it makes sense to add somehow domain knowledge into the training dataset to actually extract the right query, because yeah, the user will came from a certain domain. For example, in this, what I'm just trying to make it work. So in this case, why is my order late? Order can be in any domain. So order is not just like I don't know, Amazon ordering or something. It can be like many different ordering systems and stuff like that. And that's then specific to that domain. That also has to be part of the training dataset, I guess. The question is how to inject that, probably by generating some prompts automatically. Yeah, good, but yeah, good questions. Thanks. Thanks for that. Yeah, if you have anything, I'll just pop in. I'll try to answer. I see the comments, so it's a bit on the side to me, so maybe I don't notice immediately, but yeah. Yes, so I'm training locally. As you can see here, let me just maybe to zoom out a bit. I have these two GPUs locally, and basically only one is used. But yeah, the idea is to train them, train totally locally on a small scale to get a right training samples, and then to scale the whole thing later on, because I guess the hardest part is to actually generate a lot of training samples. For example, this is very similar to SQL case, but for SQL there is already a bunch of training samples in different repos, and yeah, there is not that many samples for Cypher, and that's on a small scale locally. I try to get, and as cheaply as possible. I mean, basically these are not cheap, these are not expensive GPUs, so generate a bunch of examples cheaply, and then later on I can scale probably the SQL is just an example of similar queries. I'm trying to do that for Cypher. SQL was just a reference that there is already a bunch of training samples for SQL, but for Cypher, that query language, this is essentially an example of a query. For that, there are not that many training samples. Yeah. Okay. Let's get back. So yeah, I'm getting coffee. Great, thank you for joining. Yeah, feel free. Probably I'll do in the following days, weeks. I'll try to expand this. So join. Yeah, I'll try to explain more and reiterate. But yeah. Sorry, expand more. But yeah. What's Memgraph? So Memgraph is Memgraph is the graph database engine, which is, I guess, super efficient and scalable in different. Can you see? Yeah, in different graph analytics workloads. I guess that's our main focus right now. It's an open source. So if you go under GitHub, Memgraph, it's an open source project on GitHub. Basically, it's written in C++. We're trying to get performance as high as possible, and yeah, it's a general purpose graph database, but graphs are obviously very good for all these RAG applications, and I mean basically RAG, and also running some agents maybe. Voila, thank you. So yeah, in that whole area, Memgraph can be used to actually extract a bunch of knowledge out of these data sets, and then in combination with LLMs, I guess you can build a bunch of knowledge base type of applications, which are quite interesting because you just take a bunch of data from the unstructured data sources, and then you run a bunch of different things. But anyway, Memgraph on its own is a graph DB. I think we are more focused on analytics rather than being source of truth. But yeah, there is a lot of applications like cybersecurity, fraud detection, supply chain, a bunch of different use cases. Does it support contextual memory? Can you explain a bit the word contextual memory? What do you mean by that? It's I mean, it's just it's a database engine, so you can store data there, and then in the context of LLM, you can actually build. Yeah, in terms of I guess you can use Graph database to actually build a system with memory. So you can add data there, and then during the prompts, it can be extracted from the database. I guess all these memory-based systems are based on some kind of a database engine, because you have to store data somewhere between prompts and having the memory. Let's call it like that. But yeah, I think you need some kind of database component, and then graphs is really interesting because you have that. I guess the main thing is there are two main reasons. One is the flexibility of the schema, so you don't need to model data upfront and spend a bunch of time there. You can quickly change what you end up in the database, what you put in the database, and you can even have like conflicting data models in the same database, because you can just store a bunch of, I don't know, data even in different ways. Interesting advantage, let's say. And the second one is the ability to have the unstructured stuff, and also schema. So you can extract information about the schema on the fly, and you can have different entities there. Please check out. I mean, obviously in the RAG pipeline use case, you can plug it in many different ways. We actually have integrations with Llama Index and LangChain, and other frameworks, other like also R2R recently and stuff like that. So I'm building a student copilot for developer. Interesting. Yeah, that's actually I'm not sure exactly what's that. You can put the link if you have, or some details, but I guess this is like a knowledge base type of use case where you put a bunch of data in, and then users can query it and extract knowledge out of the whole system. So I think graphs are perfect for that. Amazing. RAG for K-12. What is K-12? Okay. I'll move on with my stuff. But yeah, please, just any additional questions are welcome. My stream is still going, no issues there. Cache okay, yeah, all good. Yeah, understood, yeah. Okay. Wait, I just stopped here. Okay, let's train something. So based on this, because what is good here, these LLMs are generating are really good examples of the responses, but the issue is that we need exact query, not this. So the whole thing is a bit useless because we need query to execute against database, one single query, and that's it. So I already run some training, and I'll just try to manually run the training and then observe what is different, and then I'll try to build some quantifiable testing mechanism. So because a challenge is when we retrain model and when we add new testing cases and training samples, we need to be able that we are moving in the right direction. So we have to somehow have a function that will say, oh, you're better versus you're worse than the last time. And for this, yeah, anyway, let's just try to train something. Here I have the script that will train. Did I refactor that correctly? Yeah, I did. But okay, let's just commit. So just store this here. Yeah, okay, one file reformatted, yeah. So I moved, that's okay, change. Chat SLM. Yeah, let's leave it because chat SLM is just a small utility just to see what is happening. So prompt template, play model. Yeah, we have this model. We change that, we added this. That's okay, yeah, let's commit this because that's okay. We just refactored the script to generate, to have templates at one place. Yeah, let's keep that for now. Centralize templates. Yes. Perfect. So we now have that on the server. Let's train. I'll just use, so under train, where is the, train dataset is actually generating the dataset, but train is something we want to train. And here, so here we are calling, where is that part? So here, prepare training dataset. This is just removing the answer and question. So this is just additional fields in the template which are not required. But get Cypher samples. These functions here is actually generating this function is fetching the training samples, and here I hard-coded. So in this function, I actually hard-coded the exact prompts for training because I just store them locally on a hard drive so that I don't have to ask ChatGPT again for the same thing basically, so that I can just rerun the same thing multiple times if I want. So this is some kind of persistent storage for training samples. And this is now hard coded, and I just want to basically so I can just comment this out, but that's very ugly way of doing this. It doesn't make much sense to do that. I'll actually try to be a bit smarter here. So instead of doing that, get Cypher samples, I'll actually make an enum of all, because what I want to do is I want to take all, I want to be able to pick and choose between different training datasets over time on what I want to train on, and probably reiterate with different models and blah. And I think for that is the best to have some kind of an enum, just enumerate all the options, give them like a human understandable names, and then just prepare them for a given case. But yeah, I need enum plus some kind of a function. Yeah, maybe that's interesting. Yeah, if you have any suggestions how to do that, just ask in the chat. Ask in the chat. I think again the best way is to have some kind of a string, and then just map that to a function that will generate. And I probably want to have them hard coded. Yeah, I'll do that. So in a very similar way as we had before, I'll just make training sets. That's gonna be a dictionary of basically these things. So 2 prompts. So I'll just here why is that not working? 2 dummy prompts. And that's gonna be like a lambda. No, I just need a function. So get 2 dummy prompts. The reason I need a dictionary is I can make a lookup for the function, and then function will be automatically called, and I can do that programmatically if I want. But get 2 dummy prompts, and I guess I can just run here def get 2 dummy prompts. and then I need just from yeah, but thank you for joining. Yeah. Can I do this? Oh, I can use my other keyboard. All good. Yeah, it's a bit of a long form. No worries. Probably I'll also do some kind of highlights or something for the most interesting parts. Yeah, let me know what is interesting. So which parts should be explained better, or something which is more relevant for you guys. Sorry, get to dummy prompts. Yeah, 5 viewers, not bad. Yeah, please, if you haven't yet, please like, share, subscribe to Memgraph channel. There is a bunch of interesting content there you can check out. Get to dummy prompts. Yeah, I need these. This will probably fail. This will fail because of Python stuff. Get to dummy prompts. Yes. And now okay, get to dummy prompts. So I need from play dataset, training sets, and then 2 dummy prompts. So I'll refactor this into something else. So from play dataset, I need training sets, training sets, where is that now? So let's do a bit of Vim here. We can go, this is better. Training sets, and then under there we have 2 2 dummy prompts. And then because that's a function call, I need to call that function. Yeah, maybe to explain a bit of that. So the brain of the training is here under the train script. Basically a bunch of stuff from unsloth, which is all the options which are there. So we take a model, in this case phi 3.5, and then we just take that as a model. There is a bunch of options here. I don't know all these options currently, what are they, except the ones that are explained here basically, but we have this trainer class, and that to that class we are passing the training set, which are only 2 queries. So that model is gonna be insanely bad, in a sense that it will be overtrained and some local minimum will be hit. But yeah, it's just to get the training process running and to have some fine-tuned model up and running. So this will train, and then we also have save pre-trained. So I'll actually change that into that's a bit more of additional complexity. Because we need to store that as a model. Let's do that as well and try to get things right. So yeah, utils. Let's go to utils, because I probably need get day. I'll just do def gen day. Because I want to enumerate somehow my training, my model, whatever is generated. And for now, just to avoid duplication, because as you can see, I have model, Memgraph model here, and I have Memgraph model here. These are the model names. And yeah, it has to be, so this is kind of unsloth limitation or design decision. It has to be like a string. It can't be a path to a folder. So this will be stored somewhere here in the file system. You will see later on when it gets generated. But yeah, I think I have, so Memgraph model on a few places, actually 2, but also here also Memgraph model. So model name is that's actually a good point. So play model, parse model, prompt template. Let's make another Python file, which is model.py. That will be my internal model. And here from here we will take let's say current model equals something. Yeah, basically the idea here is to have here is to for now we'll just leave that empty. Yes, because current models and models. Okay, for that, I actually let me just test this script. So I can actually, so what I like to do, this is a bit of hack, but what I often try to do is let's say from utils import gen day to see if it's working. I'll just print gen day and then ss.exit one. I'll just exit this script just to see that if it's working. Python train. Yeah, the problem is that it's scripting. Yeah, I forgot the comma. Most likely. At the end of that, forgot the comma here. How did I do that? No idea how I removed that comma. Yeah, so that's working. And then, so I'll just, the model name, my model name will be something like so some kind of a prefix like mg, then to dummy. Sorry, I constantly forgot about how I name these things. To dummy prompts. Sorry, let me just delete close. Yeah, to dummy prompts, and then will this work in Python if I just run a function under this string? Boom! Python for the win. Python is the best. Okay, two dummy prompts. That will be a model name. MG to dummy prompts something. Yes. And now I'll just get rid of this. Put this here. Gen day. We don't need that part. Script here. I'll just put here at the end of that trained model name equals to this thing. So trained model name will be that. It's totally fine because when we rerun this script, this will generate a new name. That's okay because like let's say I'm doing some training today, and then in that training we're gonna have a day of the training, just to know that on that day I actually got some stuff there. I mean, obviously, like what's gonna change across days is that, yeah, we're gonna probably have, so let's get back, because for example TCK 40 is the 40 queries training set, and these queries there might be different. The problem is also that we need to somehow know about the quality there. We're gonna probably have to expand the name in the future to have some kind of a quality metric or like something there, but let's not complicate it. So for now I want a day of training and some kind of a training set identifier, and that will be the to dummy prompt name. Okay, so that, and we take the base model, we take the we put the parameters there, and then we take the trainer, and now we're gonna train on two dummy prompts. Let's test that just to make sure that we have the right thing here. So in the same way, just print that, and we exit here. No. What did I run? Because it initializes thing. It initializes everything. But now, no. The problem is that it will take my now the OpenAI is an issue, I guess. No, train dataset. Yeah, this is OpenAI stuff. What is actually OpenAI must be set either pass boom. Let's make that also better. The problem is that this thing here, when it gets initialized, if the Open API key is not there, we're gonna get to that part, but for now I just want to skip, because as soon as I load this module in Python, everything got I in the beginning of the stream I just commented out this part, but that's stupid. So for now, and where is that client needed? Yeah, the problem is that I don't want to initialize everything here. But when I call this function, I want to use that client. Yeah, not sure about how to manage the lifetime. If I put okay, what if I do this? So This may be a complete hack. Probably there is some good practice on the OpenAI site how to do this, but because this one is default, and but maybe not. If not that, print no open AI key. If not this, it should fail. Yes, this is great. So that's gonna fail if I don't have so I'll just leave it like this. I'm not sure if okay. If basic logic sometimes doesn't work. Yes, so I got these two prompts to train finally. Okay, that's gonna be okay. If OpenAPI key is here, this is gonna be initialized. I'm not sure if this is gonna work. But we'll test that later on and fix if needed. Actually, no. So to do, make sure. Okay, and now train. So we have that right. Training sets. Boom. We're gonna start here. Okay, that will fetch the two training samples. It will train the model. No. I forgot to. So trained model name. That has to be injected under here. Trained model name. And also here. Make sure yes. So this is saving the gguf file, guf file, or how is that pronounced? Let me know if you know how is that pronounced. Okay, that's it. And then we're gonna train, we're gonna save, and then we're gonna ask why is my order late question again. And now the wrong thing here from before was the size 24, like 1,000 words. Okay, I think we are now ready for to train that. I'll actually run. So train.py. We don't need that to be big. Now it's not visible on the screen. Okay. I'll just do this. Super interesting streaming setup. Maybe I can do a little bit of Tmax magic. So what's interesting here, I can do the following. So I can do like this, put it completely behind here, and then I can actually open a new window like this, and so watch -n. If you can see on the right side of the screen, watch n 0.2 NVIDIA. What is happening? No, sorry, wrong keyboard button. -n 0.2. It breaks. Video SMI query GPU memory.used format equals CSV. Yes. And now you can see the memory here, and I have a big screen here. Tmax for the win. If I do this, yeah, that will go away. Yeah, perfect. Boom. Great. Let's finally run the training. So Python train.py. Hopefully this is gonna run. Yeah. As you can see here, so the training process has started. There is a loss and a learning rate. That's interesting. I mean, the loss is super small now because the training set is completely useless because it's very specific. Sorry, it's just 2 prompts. The model will be overfit completely. Yeah, I should explain what do we have in the training set, but anyway. Yeah, basic problem now is that that's also interesting. We're gonna train faster than storing the model because the model is huge. So probably I should skip that part. That's also like a config option. Yeah, this is saving. Yeah, so basically Unsloth is actually using Llama CPP to run models. So that repo is, now we have a bunch of more things under LLM. Now we have all these, as you can see, MG2 dummy prompts. This is the model. MG2 dummy prompts goof. Installing Llama CPP. That will only happen this time. Hopefully next time it won't happen. As you can see, the GPU memory is like 2 close to 3 gigs. Yeah, I'll definitely skip that because it's too time consuming to actually save the model. So it's still saving still. So not currently, maybe we can stop what is happening here. Yeah, I'm not sure. What's the unsloth probably? Yeah. No. That's the, what's the name? Google. Yeah, it's not written in the process name, so it's not easy to find it. Anyway. Okay. Location, boom. So if you recall from the previous, before, we had this long output of the model explaining stuff. And now, right, a response that appropriately completes the request. Why is my order late? This thing here is completely wrong now because it's generated. And why is it repeated? That's interesting. Assistant is just, I actually don't know why is that repeated so many times. But anyway, as you can see, we immediately got the Cypher statement. It's wrong, but it's very much aligned with what we want to get in terms of a format, except the repetition. I'm not sure why is that there. Okay, but that's only that's the training only on these two samples, on these two training samples. And if we go here, I think I didn't explain. So give me all neighbors of a person with name John up to 4 hops in depth. So this is just a query. This was my first attempt to actually get something because this part BFS is kind of custom to Memgraph. We call that deep path traversals, and this is something that has to be trained on. But yeah, this has here neighborhoods and all these other words which are indicative of what should be there. But in the Wismar or the late query, it's completely not there, so it's hard to expect to generate this. And I have this second example, which I guess why the model is generating the right the query as this one, because it's very similar to this format of a query. So yeah, kinda. I guess for a lot of these questions, yeah, let's try that. For a lot of these questions, we should actually get very similar response, because we only have these two specific examples in the training case, training dataset. Because training is taking so fast and saving is so slow, we should skip that. So train dataset. Yeah, maybe also an idea. So from all of this, it's probably useful to extract like a general framework to actually train specific things, because like this unsloth is great, but it's just like a very basic framework, very technical framework. Some more user-friendly framework is required to actually do stuff like this, so iterate on the training. So the value proposition and what has to be solved is the easiest way to actually play with your data and to generate new stuff, and then having like a Python framework for this. For that, maybe I should publish this later on as a training framework. Anyway, what I want to do, I wanted to test with some other example, but before that I wanted to extract the saving. I'll just put that as another skip saving, skip model saving. Later on I'll extract this as a parameters or flags or whatever. I just can tweak here. If actually no, I'll do affirmative, do save model false, do save model. So undersloth ollama cpp, yeah. Yeah, why is that not going forward? I'm not sure. Let's do a little bit of Vim magic. So we can do visual block here and just move all the things there manually. Okay, do save model is false. So that's here false. That should skip all the saving. We won't save the model, but that's, I guess, fine. Why is my order late? But what can I also do? I should actually load the model and then ask the same question. So let's retrain just to see that it's working. So that will take some time. It's super fast now, and it should skip the whole saving thing. What is happening now? Wow, I never saw that much of a memory used. Yeah, okay, that's okay. So we didn't save because then the whole output will be written. That's okay. That's okay from that perspective. Additional is that we want actually play model. So we want to be able to load that thing. And so under here, model name. Yeah. So additional thing is the template. So that's what I didn't do last time. Under play dataset, no. Under train, we also here have a template. So I'll just copy that under templates. I think we actually have that as template 1. So below is an instruction, right? Yes, exactly. That's the template. Exactly. Great. I actually copied that for no reason. That was stupid. We actually have template 1. Cypher prompt templates, template 1. So if I go under train, we have prompt template equals, do I have here? I don't. Prompt from prompt template import Cypher prompt templates, and here Cypher prompt templates template 1. But now we have to rerun this again to check if it's working. Yes. Play model. And now for this thing we have to use template 1 because that's the same. So I'll try to load. I mean, now I'm retraining just to test that the script is working, but I'll try to load the model which I already have, and that's the one. So this one here, this one here. Why I can't copy this? Doesn't matter. What about here? Doesn't matter. Not sure my setup doesn't work. Two dummy prompts. Yeah, we broke something. Cypher prompt templates, Cypher prompt templates. What is the problem? Must be type string, list batch, or this. And what do I have? It's probably none. Oh, how did I do that? Sorry, this should be a model here or something. Git diff. Oh. Just a model. Yeah, by accident I completely changed that line, which shouldn't be changed at all. So good, I rerun the test. Crazy. Okay. Training again, that's all good. But since we have the model, we can actually, that's a good thing, because we can actually run, because we have another GPU, we can actually try to run in parallel. So we need to run play model. Play model should be completely okay now. What's gonna happen here? Yeah, no, we are running on the same GPU, so the same GPU. Yeah, I think that's one of the, I think I read somewhere the unsloth limit, let's say limitation is that you can train for free only on one GPU or something like that. But that's fine, we have enough memory here, so we can use stuff in parallel. So basically we got this response here from the training, and I think here we have to get the same response because boom, yes. So we have the same model running. So we loaded our trained model here. Just ignore for now that it's totally wrong, but luckily we can get that running at some point to be correct. So play model is, let's go to llama. So if we run the same thing under llama, so I'm now running, so the train model is doing something. It's completely wrong because it overfit on the training set, and the llama should give us the big response. Oh no. Sorry. Play model. I want to run this, not the training. Okay, I think I'm gonna save this and commit soon. Stream quality is okay. Luckily, fingers crossed, knock on the wood. Luckily, my internet is not gonna degrade. So far, so good. Yeah. Yeah, this is also interesting stuff. So because I forgot to write Cypher, yeah, that's what I changed. So I didn't write the Cypher inside the prompt. This is now completely different response. But it's also doing the same thing. It's just generating. Yeah. I don't want to be rude, but LLM doesn't give a fuck about anything. It just wants to complete the document and it's just repeating the same stuff over and over again. That's why I guess I got a bunch of repeated responses from the when I asked the trained model. Okay, great. But okay, we have the ability now. What we got is the ability to train and the ability to pick and choose a given model. As soon as we save, we can actually play with that model by just injecting the name here. And let me, okay, what's now interesting is that yeah, let's keep it like that. Let's not move further with changes. I'm gonna commit that, and then later on we're gonna improve the script. Sorry, what I'm thinking about is to just add parameters to actually pick the model, and also under training to save the model or not to save the model. So that's all for later. Okay, so now we can train and pick, and what's now left? So yeah, so I'll try to run on the most data that we have, these 40, it's not 40, it's like 28 or like 30 TCK examples and 70 MAGE examples. I'm gonna train on that and compare just manually what's the difference, and then I'm gonna try to go and figure out the metrics. I'll actually change this because edit. Run tests manually. Against base model, 2 prompts. I'll just do actually let's be complete. Manually against that, update comment. So we did this, and now we're gonna do this too. That'll take a bit longer, but doesn't matter. Yeah, okay. But okay, before that, let's just save. Okay. We also have I'll actually change this to mg_model so that we can ignore that. MG model, a bit of manual work. MG model. Yes, MG model, and we also play here, and we have here MG model. Yeah, what's that? That's okay. The reason why I'm doing this is just to ignore this. We actually have that already. So mg model underscore star folder. Great, it's automatically got. Do I have? No, I don't. I can remove that as well. Great, so we have that, and the black, sorry, black. Let's just format, yes. So what we did, so what did we did, so MG model is ignored. We added this. OpenAI, that might be a problem, but we will check that later on. Current model. This is not needed because we, yeah, let's get rid of that. So model, yes, not needed at all, not used at all. So that's okay. We extracted that. We played here with the models. We have these. Why is there an empty line under? No, that's okay. That's the saving. We deduplicated that, and we have the gen date. All good, great. Okay, git ct minus m. What was the templates? Play with the base model. Okay, let's now train a bit more. So we have these two, and play dataset. So I'll first copy that. This has to go, this has to be that later after. Yeah, I'll just compact this a bit, so not needed, not needed. So this is the function that will generate MAGE plus TCK plus the two prompts. That's the most advanced one. Under here we call that this, but we'll get TCK, but it's not. Why did I call that? Yeah, 28. We have 28. Not get TCK 28. MAGE case has 70. So MAGE 70. That thing. Hmm. Okay, so sorry. So here we need to be, so TCK 28 MAGE 70 prompts. How did this function call ended up here? Didn't we say that? No, we don't want function call here because that will generate immediately thing. We don't need that. We don't need that. We don't need that at the moment. ChatGPT. Play model we need. We don't need. Yeah, we need train, which is here. Yeah, we are making a function call here. Wow. Okay. Training set. Set equals to TCK 28 MAGE 70 prompts. That thing. Okay, now we're gonna train based on the the biggest data set that we actually have. Yeah. Okay. Yeah. Let's just run this because it should work. Train.py. Something else doesn't work because we removed that part from there. We changed the get Cypher samples. We have that exactly on one place. So not needed. Also that line doesn't work anymore. But yeah, if I go here, so I have two dummy prompts. I have TCK28 MAGE 70, and these are the training sets which are available. So this has like 100 training examples, and as you will see, this should now take much more time to actually train. And as you can see here, loss is much bigger now. It was like below 1 last time, and yeah, it will take some time to actually generate something. So this is now actually reasonable because we have like 100 training examples, and hopefully we can get something reasonable from the model when we run it against unknown examples. You're a bit quiet in the comment section. Just a moment. Still in progress. Live stream is good. All good, all good. What's gonna happen now? It should give me yeah, how come I'm getting these? Because assistant, I have to figure out why I'm getting these additional things. This is now reasonable because I got these results as well, and on the last training attempt. But okay, I'll actually save that model as a model, which is okay. Train. So it's not dummy prompts. Its model is TCK28 MAGE 70, and save model true. yeah, actually, we can also deduplicate this in a way that we do here training set. So we have training set, we have training model name, and we have, and it's actually, this is something that, do we use that somewhere? 4-bit models, no, this is completely relevant. Yes, 4 more models. This is something user should pick and choose, and I'll actually base model name equals this. Base model name, do I have model somewhere else? Nope. Great, so these are all the parameters that users should choose. More models at unsloth, yes. And now we have enabled saving, so let's save that model. And then we're gonna try, so actually, so I won't do this because it's the same and it works worse. So I'll get rid of this. And this is okay. That's what we did. As soon as I get this running, I'll commit again, and then we'll switch to the validation of these of the models. I have to, so I have to save so that I don't have to retrain again, and then we'll just play with the Deepevel. I'll explain what that is a bit later. So just let me finish this. Something super simple. Yeah, this should save the model. So yeah, we still have dummy prompts, and okay. So we got this done. Yeah, base model, 2 model prompt, 40 TCK. Yeah, I'll actually skip this for now because, so 28, this is wrong. Actually, I don't need this. 28. Okay, let's do Deepevel setup in the meantime. So, Okay, a step back is that once we have a generated responses, we want to verify how good they are. I have no idea how to do that properly, and I have no idea how, for example, OpenAI does that, or other companies. Happy to, if you have some knowledge about how to actually test and validate fine-tuned model and responses, let me know in the comments. So far, like from people I talked with, I just got like, yeah, I do that manually by like a human is actually reading that and figuring out how to do that, how to have valid, how to test and assess what model is better. I stumbled upon this framework, LLM evaluation framework, which does all sorts of these metrics, G-eval, summarization, answer relevancy, faithfulness, and stuff like that. So I'll try to get this working. So far, I haven't played with it hands-on, so I'm not sure how hard it's gonna be to set up that. But let's try to install that. Pip install Deepevel. Yeah, this is saving. So for the first part, so this was the unsloth setup, and here we have the training stuff, and then let's just add another section. We don't need you here because we are running on that virtual environment. Okay, yeah, the whole thing finished and the model is hopefully saved. Yes, we have TCK20 here and MAGE 70. And let's try, so, okay, let's just commit this first and then we'll move on to another thing. So, play model. So this is the dummy, but I want TCK28 MAGE 70 prompts. And now if we run this Python play model, this should produce the same result as this one. I have to figure out why. That's one of the things I have to figure out, how to stop generating these repetitions from the unsloth. I guess there is some way of doing that, but let me just try this, install Deepevel, make some simple example, and then we'll deal with that problem later on. If you know, if you had some experience with unsloth and how to stop generating this, let me know. Yes, I got the same response here, which is great. Okay, amazing. So now we have this model. Double check. So we added a new training set into the index. We pick that when we play. This is we use that here. Base model is 3.5. Training set is this. Model name is this. Yeah, now it probably makes sense to actually introduce the model, but anyway, we'll do that later on. Okay. Let's store that on GitHub safely, so if something fails, I'll get back there. Amazing. Okay, Deepevel. Deepevel. So quick start. Let's copy that again. Init bash. We need here. Yeah, usually this is not the standard way of doing what I'm doing here. It's not the standard way of installing things. But since I'm playing with a lot of libraries all together, I like to have a bash script that deals with a bunch of different issues on different systems, so we can actually have that stored somewhere and rerun. And for example, here, just a comment how to deal with that particular problem. So this is not a standard way, but since I'm playing, I think it should be fine. Let me know. Yeah, again, additional, happy to learn how to actually deal with custom problems and custom templates. Usually people do Docker or something, but that's additional overhead. I think this is like much nicer to actually experiment in the first place. Yeah, I'm trying to optimize a lot for the experimentation and stuff like that, so avoiding unnecessary dependencies and unnecessary components in the system too early in the process. Anyway, that's it. Let's run this. This is now completely init bash. This will take some time, but I think a bunch of these things will be cached now. Hopefully nothing's gonna get... Yeah, everything is installed. Get in. Yeah, it's already close. Yeah, what is interesting here, because yeah, I might have an issue here because Deepevel is actually installing all sorts of things that I already have on the system, because Deepevel is also probably depending on a bunch of... Yes, so attempting uninstalling. Yeah, this is a problem. This is a problem because we need exact version of protobuf to actually store. And now we get to the point why it's interesting to have the models. So now I have to, again, software engineering problem. Now I have to verify that I didn't break something in the training. And I'm very confident it's gonna fail because we installed some other version of proto, and we can actually pip freeze and then grep protobuf. Yes, exactly. So this is 4, and that's gonna fail. It's not gonna work in my setup for some reason. So, but what I'm gonna do, I'll just move protobuf in the end. Yeah, let's do this. I think this has a high chance of success. So what this is gonna do? First, this is a bit of a problem with dependency resolution and stuff like that. I think probably Poetry or some other system have a much better way of dealing with this, but since I'm using pip here to be minimal, I think this is gonna be okay. Boom. Oh, no. Pip dependency resolver does not currently take into all the packages that are installed. This behavior is not source of the following dependency conflict. Incompatible. OpenTelemetry. So OpenTelemetry requires protobuf, which is incompatible. That's a problem, but we don't need OpenTelemetry, so I'm not sure. This should be okay. If we run Deepevel successfully, it's gonna be okay. But let's try now to run our training, because training with saving of the model. But to make stuff fast, we're gonna do to dummy. We're gonna use two dummy prompts, and that should actually load two dummy prompts. So Python train py. So this should run two dummy prompts again. So this is now completely redundant, just to make sure that everything is working as before, because we are playing with protobuf. Protobuf is required to store the model. Without this protobuf, it didn't work before. So now we run the training as fast as possible, and we're gonna try to store the model again. And if that passes, we should be good. Except maybe Deepevel won't work because we have another. So I think here, if we do pip freeze and then grep protobuf 3.18. So this is okay version for unsloth, but not for the Deepevel. Open telemetry from the Deepevel. So hopefully, so this is now, this might take 5 minutes for llama 7b. Yeah, this is a bit misleading comment because I don't do 7b, I do like 3.5. Yeah. Okay. Yeah, I think that failed. Yeah, the process failed before on another place, so this should be fine. Okay, that's okay. And again, as you can see, ordering here is important to actually get stuff done, get stuff okay. Although optionally creating an account wrap will allow you to test results, enabling easy checking. Yeah, I don't want to log in. This is all public data, but I don't like the concept of login here. But it seems that this might be optional. The problem is also that this needs LLM to work. Yes, I need the extremely modular, making it easy for anyone to use any of our metrics, continuing from the previous example. Oh no. Okay. Yeah, this is okay. This is the right example. It's all working now. Okay, deepeval. Can I run this without server access? Anyway, let's try to get deepeval evaluate. Let's try to get this running. Play model, yeah. So I'll just make this as a function. Here I have to run. Okay, so input, actual output, retrieval context. What is that? So we have some relevancy metric, and I have some kind of a test case against which to evaluate. Yeah, okay, let's try to run this. This should explode. No. Now we have message types by name. Now we have issue. No. Now we have issue because of telemetry. That doesn't work because we have wrong package name. Proto, yeah, as you can see here, proto doesn't work. That's a problem. That's a problem because I mean, in this case, we don't need proto. In the second case, we don't need. What was the problem when saving model into the GUF format? The follow exception, the scripts created directly if this call came from. This is what I did. I downgraded to protobuf package. Yeah. I'm not sure what's the best workaround here, except duplicate these things to not waste time. this is a super stupid problem. Yeah, to not block us too much, I'll just do the following. So init actually no, init is okay. I'll just to avoid copying the whole file, I'll just do the following. So if the first argument to this script is equal deepeval, in that case I'll install deepeval. In the other case I won't, but I'll do that at the end. Maybe I'm doing some wrong, so I'll just put here to do, try to I'm sure Poetry or some other package manager can deal with that in a better way, but I don't know that in a good enough way. So I'll just have these two options in the init for now. And basically when I need deepeval, I'll create another virtual environment to use deepeval. So that's it, yes, and then this is not gonna work, and I'll just start virtual environment. So I'll create another one, virtual env min -p python 3 va3 deepeval. Yes, and then here I'll actually source v3 deepeval activate. So that's deepeval virtual env now, where we have to install with deepeval flag, and that should install the right version of deepeval dependency. Yeah, the biggest problem is now that deepeval and unsloth need different versions of the same library. And for now, we'll just make two cases that will work in our with our assumptions, which is not the best solution overall, but just to not waste too much time on the proper resolution of that, I'll try to solve that in the meantime somehow better. But the important thing is that under VE3 we have proto should be 3.18, yeah, and here we should have proto 3 point no, pro 4 point something. Uh, ah, uh, ah, a little bit of bash magic. This should be now okay. Yeah, a bunch of you joined actually today. I'm a bit surprised by the number of concurrent viewers. That's great. I'm hacking here a bit more than I expected, but yeah, this is completely new for me. The Deepevel thing, probably we're gonna also encounter a bunch of other issues, but let's keep going. If you have any specific thing, so here pip freeze grep proto. Yeah, this is correct. So for this should now work. But yeah, now Deepevel and Python play model. They should now fail because I don't have OpenAI key. Yes, I need OpenAI key. Now it gets interesting because I need to provide that. Is there a way to use Deepevel? What is that? Nothing, sorry. Is there a way to use Deepevel without open? I have it. No, sorry. I have it here. It's funny. Yeah, Deepevel login. No, I don't. I just want to run locally without. Sorry, what is the answer relevancy metric requires Deepevel metrics introduction? Answer relevancy. This one requires, I guess, LLM. But what is GL? Is a framework that uses LLM with chain of thoughts. Okay, let's try to use this one. This one maybe does not require, even though it says And let's try to use this one. So relevancy is a bit of a problem. Let's just unsloth comment out this because it takes time to actually no. This requires a bit more time because it will generate the thing. Let's just we will have to integrate this under this script, but to avoid issues I'm gonna create play eval, another if name equals main. Let's try to run this. Python 3 play eval. Yeah, all of that requires API key. Maybe this one doesn't. This is a bit, I'm doing a bit of a brute force attack here to figure out what's gonna work and what's not. So let's def run geval. Bias. I'm just trying to run something, so because there is a lot of options and I should probably play with all of that later on, but just try to run something that will give me some kind of a metric. Sorry, what did I do here? I have the key. Katarina is sending. I have the keyboard for it. Where is my pointer? Kate, I have the key, but yeah, I want to run something locally first. Where is this? Play model. Good. Yeah. Thanks for joining. Ask some question, which is interesting to you. I'll try to cover it. But yeah, sorry, let's get back here just to make this something running. Bias, run bias. So a bunch of stuff. Actually, I was I run basically it's explained under yes. So whoever is currently here, a few people. That's great. I love concurrent users. So let me just so far I just rerun all the steps here with training the model, but basically I just get the whole setup so that I can run the base model, I can run the two prompts model. This is just overfit model based on two example Cypher queries, and then also there is the third one which has like 100 training samples. So I just trained all of them multiple times and saved the models locally, and yeah, basically getting the infrastructure running on that side. And now the next step is to figure out how to actually evaluate these models, and I'm trying to get Deepevel up and running. And then whatever these models will generate, I will actually evaluate that by using the Deepevel or some of these other methods. So running Memgraph, running queries, running generated queries against Memgraph, or like assessing if there are any results from the query, because on a given dataset there should be some results, and then running that over or over again. But yeah, we'll see how much I can get today out of these things. Yeah, okay. Let's get back. Geval. Thank you. A lot of luck needed. Run bias. Run bias metric. That also. Oh, everything requires OpenAI key. So let's get one. This is a bit shame, because what if someone doesn't have a subscription? Let's run bias. Yes, we have these biases here. Sorry, these evaluation functions. ChatGPT. OpenAI login API. What is my? Have to log in with Google. Will this work? Yes. API platform. Yes, I need the key. So yeah, I actually have a paid version of ChatGPT and OpenAI. So not sure if you can get something running without, if you can get API running without paid version. I'm not sure exactly what's the current situation, but yeah, I need. Where is the? Members limits. project. No. Yeah, and now sorry, where is the oh, I didn't see that. Create a new secret key. Read only project. This one. No. Copy done. Okay, I have it here. If I go back under git ignore, open API key. I'll just API AI API key. Is that the right API key? Yes. To have the key stored here, and then I think OpenAI API key. So export OpenAI API key equals something, and now play eval should work because I have the key. Boom. Missing scopes. Now I have some permission problems, I guess. You have insufficient permissions for this operation. Missing scopes model request. Check that you have the correct role in your organization. Reader, writer, owner. And if you are using a restricted API key, that is yeah. Is that explained somewhere on the page? Deepevel. Seems like my mouse has died. No. Seems like my PC has died. I guess you can see me. Still, yes. Yeah, now connection is excellent, but my what did happen? No idea. Let me do a quick break because seems like my connection is dead. Sorry, my laptop is dead. Yeah, be right back. And we back. My PC still doesn't work. I'll try to restart. Sorry, just give me a few seconds. And we back. We back. Not sure what has kept me. Can you hear me? Yes. we back here. Okay. Let me just ask me later. Which is great because my PC died for some reason. I'm not sure why. It completely froze. But since I'm running this on a server, the whole thing has stayed the same, which is amazing. Let's move on. So we have the API key, but we don't have the guest mode. Thank you. Live support came in. I just got some protein shake, which means 3 more hours. Kate, are you still here? Oh no. Because it's a guest. I have to log in again. I can't find it. Was no. Where is the? So create API key in the dashboard here. Boom. Project, no default, fine tune LLM. Boom. Here. Yes. And now this API key, edit key, restricted models. Right. And what is needed here? You have insufficient permissions, reader. Yeah, it's a problem if I do all this is actually like a security breach. This is like not great because I stream live, but yeah, I can take a risk and then remove the whole thing. Models. What is press change may take a few minutes. All models read. I guess everything is then read. Read only is read across the board. Um, insufficient permissions. Yes. I can actually try to use local model as well. This is an option because I have. Let's do that. I can actually set up the local model to run this instead of leveraging ollama. Let's install ollama on Linux. Install ollama on Ubuntu 4. What is this? Ollama. Okay. Install ollama. Boom. Now we are storing. One interesting thing, because I have two GPUs. I can use one GPU to run like a local LLM model. How long this is gonna take? Who knows? Yeah. Deepevel set to configure ollama, use the following command. API key ollama. Deepevel unset. Yeah. This is actually very good. Yeah, we should do that. We should set up Ollama to use under Vim and all these things, but we'll do that. Why is it so big? It's okay. Ollama. How to pick a GPU. Small GPU MD, yes. Support by running. If you have multiple GPUs in your system, you want to allow to use a subset, you can run CUDA visible devices to separate list of GPUs. Aha. This there, haha, yes. This is great. So we need CUDA visible devices. You can discover the UUID of your GPUs by running NVIDIA SMI-L. So if I run NVIDIA L UUID area, and how does that CUDA visible devices example? No. Analytics, yeah. Sorry. CUDA visible. CUDA visible devices. I want so okay, not ollama. I'll document a bit what I'm doing here. So under int UID is recommended. GPU 1. GPU name 01. I think 1 is used. 0 is used by yeah, but that also applies to the same thing. So I'll just use Huh. Yes, 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 yes. Creating ollama, enabling and starting ollama service. But ollama list, I think. Yeah. How to see which GPU is actually used. Let's experiment. So ollama. Ollama is running, but where? Server is running. Pull llama 3. Now installing. That might be a problem because of the disk space. We have enough. That's gonna be enough. Yes, but okay. How to for the training? Look at this. Look at this. Haha. Ha 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 ha. Yeah, this is too big. Train. I think for here. OS environ. Let's do one. Could have visible devices, and now if we train, that should actually train on the second one. So here, this one should go higher if I do that. So if I Python, oh sorry, which one is the, well, I want small model to dummy prompts. Yeah, train. This should now pick the second GPU I have. Yes, haha. Yes, yes, yes. This is amazing. This is amazing because now the second GPU is used instead of the first one. So meaning that we have 2 GPUs on our disposal. Amazing, amazing. What else? So, and I want to ollama. I want ollama make to use of my second GPU. Yeah, this will take a bunch of time. Okay, let's get back to documenting stuff. So ollama execute. Like there are two possible ways. One is this one. So Python. From Python we do this. Set spell. This is actually, how is that? How is that pronounced? UUIDs. That one here in Python, and bash is export thing. Yeah, that thing here. How far are we from? Not close. Okay. So ollama, but probably I won't be able to run that under my GPU. Anyway, doesn't matter. We'll see when we hit that problem. Okay. Also, while this is running, let's just do all save. So let's now give all the permissions. And now if I play Python 3 play eval, this should now have the permissions. Still doesn't work for some reason. I hate this. Maybe it takes some time to actually propagate, so we'll wait for that. This is to get to list of devices, and then we do CUDA visible devices. We trained here, but this is obviously not the best, so we'll avoid this because it might fail on the systems which have only one GPU. So remove that from here. Python train, that's okay. What about the eval now? Yes, it works. Haha. The score is 0 because the actual output is unbiased and exceptionally well balanced, showcasing an equitable representation of different perspectives. Lol. Just a second. What is the we run the bias. What do you think about autistic people? Sorry, I can't write use of people living without. That was the example. Okay, that's fair. But run bias, and what about and 0 score means okay. And what about GAval? This was successfully done, but